Hi guys, I'm going to be sharing the STL of my printed in place RC car. Get out of the frame. It's not finished yet, but I could use the feedback from some of you guys. So consider this a beta test release and print at your own risk. This is going to be a tutorial to help you set it up on the slicer, get it off the print bed, and then put in the electronics. So this is the first printed in place RC car that I designed. And it's actually a modification of something I worked on in August, which was a printed in place battery powered car. So, you put the motor in the battery, blah, blah, blah. There. So this became this. And then I figured I wanted to look a little bit more car-ish and have a little more grip. So I modified the mechanics to be a little bit more offset, and I managed to put in some tires. Grip was still not great. And so I made some tires with treads on it, and I also made some mechanical improvements for the now offset mechanism. You see how the front of these guys is? They all have this bar on the side. That limits kind of the steering angle, and it also isn't that pretty. This is what it prints, the way it printed off the bed plate. You can see there's this guy. That's not an aesthetic choice. That was there for the support beam, which was necessary for how the steering system was printed. I want to get rid of that, and I managed to do that. So this is I guess the next iteration. It should be here. And as you can see, I didn't break anything off. This is actually how it comes off the build plate. Oh, right. I also made it a extended version, like a limo. The reason I did that is because things are a little bit compact in here. This is 132 scale-ish, like a mini four-wheel drive. This is Mini Z. Here, get over here. So you can see the wheelbase is more similar. So that's about 80 millimeter wheelbase. This is going to be 98. So let's get started on what you need to get this set up on the printer. Okay, I'll put the information on Thingiverse, but I designed this so it's printed at 0.2 millimeter height with supports off, brim off. That's really all you need to know. That's it. I like to print mine in PETG because it's stronger, but they will print in PLA. This is PLA. There are little details that there are little like micro supports that are in there. So you don't have you keep supports off, but I already included some tiny little supports in different places. And I'll talk more about them when we get this off the print bed. Well, not this one. So that's the tutorial chassis I decided to go with. And actually, because this is PLA, and PLA tends to be a little bit more fragile, I decided to print a backup in PETG. So you got that. And because those are both short chassis, I wanted to do one in the long version. So when you see the STLs, you're going to see a couple of different ones. You're going to see this one, which I call the standard, and that's the one with all the holes. Then you're going to have standard stretched, which is all the holes, longer wheelbase. Then there's going to be one with no holes, which will be called full or something, and then blah, 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 blah. I'm going to start with the more fragile one, the PLA. All right. The most important thing is obviously your bed adhesion. You might even need to print this with a brim, which you can remove later, depending how good or bad your bed adhesion is. Well, that went pretty easy. Okay, so let me start with this part over here. This is the top left wheel. Okay, so there was I should have. Oh yeah, I got a scaled up version I can show you. I made some micro studs. This is obviously 2 times bigger, but there are some micro studs that hold this wheel in place. So what I like to do is I like to grab this and hold this part steady. Is this not focused? Okay, and then twist this. The next part we're going to do is the bottom. And you can see, did I remove them? Oh, I already removed them from there. But there are little, like a square. There's like square layers right there. So same deal. Try to find an angle. Like I like to do it like this. And twist. Nope. Oh, yeah. Wow. Okay. Okay, so that's free. That's free. This is now, in my opinion, this is the easy part. I just grab the gears and I pull them together. And if it hurts your fingers, you can just use these, as long as you don't damage the teeth like that. You know, you can pull them. I would start with these guys. Okay. You do that, and that's free. Now we come to the motor holding thing. So we got, you got a little piece there that's connected, so you want to pull that off. You want to pull this off. You want to pull, it might be a little hard. Okay, for this one we're going to use tools just to be safe. So there's a little piece here you want to disconnect. And then there's actually another one there. It's kind of, I usually can do it a lot quicker, but I have the camera right in front of me. Okay, so these are free, and there are also some little sticks up here. You want to lightly pull this in place, pull this back. Come on, baby. Don't break. Don't break. Mother trucker. Okay, so if that happens, the way you can keep this usable is just, where is it? You basically just take tape after and you wrap it around, kind of like I did here, and then you can still use the chassis. Kind of sucks, admittedly. Like I said, if you're printing this, it's on you. This is a beta version, so you know, don't come yelling at me. Well, I mean, I guess you can because I designed it. I'm working on it, okay? I'm working on it. So the idea is you pull that back, and then you pull this up. You'll hear a little bit of cracking, but basically after that, that's free, and you know, that's where your motor goes. So let me see if I can do one without breaking the piece. PLA is going to be a little bit more brittle, but with PTG, it's going to have a higher rate of survival. So I'm going to do this a little quicker. So we're back where we were, and you do that. And if you can't get it, come on, there you go. I think I can do this without the tools. Okay, now watch, it's not going to fail with PTG. It has a little bit more flex, and the layers adhere better. And as you can see, ta-da, it worked perfectly. So now let's get to the more complex part. So the steering mechanism. So what you're gonna be experiencing is, man, it's hard to see. There's gonna be some little bridges here and here. And then there's gonna be, where else? There's gonna be like one over here, and then like one over here, over here. There's going to be a couple of bridges. So examine, you know, it's hard to show this on the camera, but make sure you examine it before you go at it. So one way you can do it is you can, maybe not with those, but with this, you can kind of do that. I didn't cut anything there, but if you do see the pieces, you can cut them off. But the way I like to open the steering, come on, is to just seesaw it. Are you okay? Are you okay? You're okay, right? Of course you are. You're PTG. Not like a stupid PLA. Are you okay, though? Nope, we're good. Whew. So there you go. So now you have a fully functional rolling chassis. Let me do it real quickly on the on the longer version, just so in case I want to do the electrical build on this. So, you know, once you get used to it, you can do this pretty quickly. So these are already free. This is my favorite color, PTG. It's by Solutech. It reminds me of those little Lego space antennas. There you go. This one went by pretty quickly. Now we go to the front steering. Oh, this one just behaves properly. You'll notice that everything is sticky, right? First off, you might not have perfect circles depending how good your printer is. And there's little pieces you can hear crackle. Those are just the different little micro supports I made that are kind of just rolling in there. So Honestly, one way to get rid of them is once you put a motor in, to just break it in. And just put any old motor. You just are trying to break in the gears and the wheels and stuff. But the thing that will help you the most, really, is this or this. I'll do it on the longer one so it's easier to put stuff in. It's already starting to feel smoother. Oh yeah, another place that you want to probably put some oil is over here. So this whole shaft. You can also print your tires like I did. I mean, I'm going to include the STLs for both the tread tire, flat tires. Yeah, that's it. I'm also going to do a slightly wider version so you can do drift tires. I tried making one. This is a little tight. I actually had to grind down the wheel to fit this, but I'll fix that before I put it online. If you don't want to print your tires, you can just use Mini Z tires, which are really soft and rubbery. They work well. These will fit fine, but they are a little loose, so double stick tape. I have these sponge tires from my mini four-wheel drive hobby. They work really well, and these particular ones have a lot of grip. They're called Reston? I'm not sure. They're called this. Yeah, that's it for tires. So let's start building this thing. Depending on the battery you get, you might need some conversion plugs. So I had this from one of my quadcopters. You can buy something like this really cheap, and then you can just make every plug the same and just make it easier to plug and unplug stuff. So this guy is now old and obsolete. Goodbye, my friend. Out with the old, in with the new. The important thing is you're going to need to stick the electronics down, which I need to clear off here first, of course. So I cleaned the double stick tape off the electronics. I separated them. I cleaned some of the boogers off the print that were on mainly the circular parts. I just used an X-Acto knife and cut everything. I was thinking how I want to mount the electronics. I've considered mounting the more powerful 2S battery. I could, in fact. There is like plenty of room. But I would have to mess with cutting the wires, and I want to keep this tutorial simple. I also really wanted to put the servo over here, because I just think the nose would look cooler if I didn't have this guy in the way. And it's really close to fitting the way I had it planned, but it doesn't leave a lot of room for me to use the hook to put the motor in and out. So I want to just make this easy and quick, so I'm going to go with the classic servo in front like I've been doing. If you have, better skills at Tetris or smaller electronics, maybe you can fit everything in here. That'd be cool. So how do we go about this? Well, I may not be using the 2S. I'm going to use this guy, which is bigger than the previous battery, so it'll last longer. It's a 1S and it's 500 mAh, and I'm going to have this be here. I'm going to have the receiver be over here, like so. I'm going to have the servo, unfortunately, go back up front, and then the speed control is going to be on top. So it's going to be actually the same that it was on the other side, but I obviously have a little bit more room to play, and the extra wheelbase length will help with, well, I had a lot of not steering, but spinning out problems, so that extra wheelbase will definitely help. And of course the motor in there. So let me start with the battery. Okay, so we grab this. Would you know it? I forgot another tool. The scissors. Oh, wait, wrong ones. They're still a little big, but they'll do. A square of double stick. That will measure approximately the same as my part that I want to stick down. You could use glue if you really want to, but this is a 3D printed chassis. It's going to break pretty quickly. So you want to have your parts, detachable, so you can use it on the next one that you print. And then when you break that in 5 minutes, you replace it again. Yeah, that works. Oh, ain't that pretty? So we got that there. I want to leave enough room for the hinge thingy here, so I'm going to place that about there. Okay, that should work. Wow, I'm having the hardest time grabbing this piece. There you go. So what did we say? We said over here, right? Right on top of the battery. Now I need to connect the servo and the speed control. Well, I'm dumb. I accidentally used the wrong remote and I plugged these in the wrong holes. So this is actually channel 1 and the speed control is channel 2. Duh. So let me just, so, you know, basically it's on and it's zeroed where I want it. Yeah, okay, so I know that I want my servo this way. So I want the servo arm to be up approximately at least 90 degrees or close to it. Let's talk about this piece. So this is just a piece I made out of a fiberglass that I had laying around. I just drilled 2 holes in it. One hole is big enough for the screw that goes into here. I forgot if that screw came with the servo or if it came from my pack here. But these are like smaller than M2. I'm not sure if it's an M1.6 or M1.2. It's definitely not an M.1. And then on this other side, there's a hole big enough for an M2. And I'm gonna be connecting that side. So I'm gonna put this here and the M2 will screw the servo arm into the steering hinge I designed. So it's a 2mm hole. Okay, well that's in. And that's a little too tight actually. I screwed up. I need to back it out a little. Don't make it tight, make it able to move. But now, once I placed the double, I keep thinking double stick gum, but I'm on to say double stick tape, we can now just figure out where we're gonna tape this. So that's what I'm gonna do now. All right, I got the double stick tape on. So now it's a matter of aligning this so that the wheels are straight-ish. That looks straight to me. Pressing down. And hopefully I didn't screw this up. And there we go. Oh, don't move, come on. The tape might just be a little weak or I might need to clean the holes a little better. But we have, you know, steering. So now we're going to install the motor. And, well, you could solder this directly to the speed control, or you could solder this to a plug, which then plugs to the speed control. I'm not going to do any soldering because I like to reuse these for other projects. If this was a more permanent build, then yes, I would definitely solder a plug to this. I think I want black over here, and this is how I'm going to do it. I want red here, and I bend, and there you go. Okay, that is the correct direction. So with that installed, no, you don't really need to cut these off. And the chassis was originally designed with the, what do you call it? Damn it, the brushes to go facing down, but it's just a lot easier to do this. So you got that in there. Hopefully everything will go to plan here. You pull this back. So pull this back. And it goes there. And there we go. Now, the gears should be aligned. It should be turning. If necessary, push your pinion up or down. And let's see. There you go. You officially have a working remote control printed in place car with no tires. So it didn't occur to me earlier, but you can actually use zip ties to tie stuff in place too. Another thing is that there might be a little bit of friction between the parts if it's not a clean print, and sometimes it can happen. So you'll probably want to run this for a while. What I like to do is I like to plug in 2 AA batteries directly to the motor and just hang this somewhere and let it run. And with time, it'll wear in any imperfections so that it'll run really smooth. And, you know, as long as you put some oil on it, it won't wear it to the point where it's unusable. Better yet, if you're using PETG, it seems to wear a lot less than PLA. I ended up zip tying the wires together and just leaving them on top. There's the servo wire. It's not in the way of, you know, the tires when I install them. And yeah, so electronically, this is ready to go. Zoom in, fool. I actually placed the switch here on top of this piece of plastic because it wasn't really attaching here. I think maybe my bioadhesive tape is just kind of dirty, and that's why, or maybe it's just the PETG, I'm not sure. But anyway, I put it up here, and that's fine, it works. So let's go with the tires. I have mentioned some of the options earlier. I do plan to try this out with some different tires. So I'm gonna go with the TP since I really love how they look and I haven't used them yet. So for now, just for completion, I'm gonna mount these, but when I do a little bit of a trial run after, I'm gonna try these. I'm gonna try the Kyosho Mini Z tires, and I actually ended up reprinting the hard plastic tires. So I'm gonna try some Driftu. This is officially complete. I don't think I missed anything. Bodies. Well, bodies were not really my priority while designing this. I do plan to have it so that you can mount bodies on it, but it was difficult enough to just get this whole thing working from the start. I have a Kyosho body here. It's got these little plastic pieces so it won't mount, but technically you can fit it in a Kyosho body. Just have to make some mods. What else? You can find this on Thingiverse under Rock Racer, I believe. He makes a lot of these bodies for what are called OpenZ, which is 3D printed Kyosho Mini Zs. And I love the Countach. This would fit, but I have to modify the bottom. And the wheelbase is about right. So if you're wondering, this is 98mm wheelbase. This one's 80. By the way, you can also get, if you have like one of these old Revell kits, or you know, what other brand, these might work too. You know, I'm not the creative sort, so I'll leave that to you guys. For the 32 scale, mini four-wheel drive bodies don't fit well, except for the Lexan ones, or clear body, whatever you call them. Here's an example. This guy here. This guy would fit really well. I just need to make some connection, and you know, you can probably tie or glue something onto the frame, or you could put the body on. This is about right, yeah. What other options? Oh, this one, yeah. Here's another good one. So these that I'm showing you right now are Tamiya mini four-wheel drive clear bodies. We covered the body. Upgrades. There's not really a lot you can upgrade on this right now. There is a hole in the back, so if you want, you can preemptively reinforce this, or you can just wait till it breaks and then glue it back together. This is, for example, a 2mm hexagonal axle from Mini 4-wheel drive, and you know, you can glue this in there. Right, so now I didn't glue it, but you can. But right now the axle is reinforced, so you know, this will be able to take a little bit more of a beating. I think that's it. I'm gonna showcase some test runs. So, test runs. So it's actually raining outside, so I'm gonna be driving it here instead of the street. First, I'm gonna try the Ninja Flex tires. Okay, let's give it a shot. So it's a little bouncy, and I think it's because of I printed it as a single line on the outside, and so there are some imperfections for where the extruder stops and starts the next layer. This can be cleaned up with just like an X-Acto knife, or there's some cutters, or if you make these are the treaded tires, maybe with the with the smooth tires, you won't have this as much of a problem like this. Or with thicker tires, and then you can just sand them down. But I have to say that actually the Ninja Flex offers more grip than I thought. Alright, these are the TPE tires. I don't expect a better result. And I'm going at about 30% throttle here. Any more and I'll just start slipping around. But I can't tell a difference in grip. Yeehaw! Okay, yeah. If I trim a little bit, they will run smoother. But yeah, that's pretty good. All right, let's switch tires. Something that might happen to you, especially if you have pets, is getting hair stuck on the axles. Just use a needle or some pliers or something and delicately pull them out. Just be careful. Next up, Tamiya Reston tires. I should probably have trimmed them down, but I'm too impatient and I just wanted to see it run. So here we go. Oh, I definitely feel more grip here. Woo. And a little bit more ground clearance, so I can even go over the carpet thingy there. Oh yeah. I'm still, if I throttle it, I still lose control, but definitely have a lot more grip with this. Where'd you go? Oh. So, it's probably stuck on a leaf or something. So let's try the Gyosho Mini Z tires. So the front tires fit perfectly fine. The back ones are a bit too wide, and I put some double stick tape. And I should have cut it, but I just pushed it in because I want to get the show on the road. So, definitely, I can't tell if this has more grip than the rest-on tire. What the hell's going on? Oh, I can't tell if it has more grip than the rest-on tires, but it definitely has grip. And the only problem is that it has a lower center. They're smaller diameter, so you're more likely to hit the ground with the underbelly of the car. It stopped raining for a second, so I'm going to do a quick test run on the concrete. Maybe I should get in front of the camera though, huh? Definitely more grip here. Ah, right into the water. I'm going to test the drift tires for the first time. And I don't know how to drift at all. How the hell do you guys go straight? I think I covered everything you guys need to start printing and driving this thing. If I did forget anything, please let me know in the comment section or on the Facebook groups or on my Instagram. I realize this was kind of a long guide, but there was a lot to cover and I went into it kind of unorganized. Sorry. But if you made it this far, yay! Thank you for watching and I hope you enjoy it. Blah, blah, blah. Okay. So, yeah, remember, beta test.